Hey everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to jump into Lesson 8.4. And Lesson 8.4 is on page 285 in your books, 285. What we're going to be doing today is talking about multiplying radical expressions. These are radical, man, and we're going to have a lot of fun doing this. So, adding and subtracting, you had to make sure that you got them to be the same, like similar or same terms. And so like if it says square root of 3, the other one had to be also square root of 3. Well, in this lesson, it's not like that. It's a little bit easier to multiply. I think you've been finding that out in algebra, that it tends to be a little easier to multiply in algebra than it is to add and subtract. So let's look down here at the screen. Let's jump right into this. All we're going to do is multiply just like they were variables, like 2x and 3x, okay? And so we just multiply the x's together. It's going to do the same thing. We're just going to multiply these numbers together, the square roots together. And so 3 times 7, that's all we do here. And that's going to equal, it is the square root, because obviously these are both square roots, of 21. And we're done. That's it, okay? In this question. Now, if you think, man, that's the easiest math lesson I've ever learned. Okay, just wait, there's more. Okay, don't worry, we're going to get to some more difficult ones. But that right there is a pretty easy solution. You just multiply the 3 and the 7 together, you get square root of 21. Now, what do you want to check on this before you circle that answer? Here's what you want to check. You want to check, does that solve out? Can I simplify that? In other words, are there any perfect squares that can go into that? What are our perfect squares? Well, 4, 9, 16. Do any of those go into that evenly? The answer is no, so we would circle that answer. Okay, let's go to the next example. 10 square root of 10 times the square root of 2. Again, we're just going to multiply, and we're going to get the square root of 20. 10 times 2 is 20. Now, again, you have to ask yourself, don't just circle this answer. You have to ask yourself, can I square factor that? So let's write our square factors again. 4, 9, 16. 16 doesn't go into it. 9 doesn't go into it. Oh, 4 goes into it. All right, so you're going to have the square root of 4 and the square root of 5. What comes out? What is the square root of 4? Well, it's 2. So this answer would be 2 square root of 5. Do not circle the answer 20. 20 is not the answer. We have to simplify our answer, okay? So make sure that you're remembering how to simplify. We've done that in previous lessons, okay? All right, let's keep going. Next one. One's a little bit different. Now we're introducing a letter here. So what do? And we're introducing also something out front. So what do? We do it the same way that we would do it if it was a variable. So if we had 3x times 3y, okay? We would multiply the numbers, and we would get what? 9. We'd multiply the letters, and we'd get xy. That would be the solution there. Same principles are going to apply here with the square roots. So what we want to do is we want to say 3 times x, and that's going to give us 3x. That stays outside because it doesn't have a square root sign. Now we're going to multiply the square roots right here, and we're going to get 6 times 2 is going to be 12. Now we're not done yet. Why not? Because 12 can reduce. Why? Because our square factor 4, 9, 4 goes into it. Okay? And so that's going to square factor to 4 and square root of 3. What comes out of the 4? A 2. Now be careful of this. The 2 comes out, so what do we do with that 2? We have to multiply it by the 3. 3 times 2 is going to be 6x, and then we're going to be left with a square root of 3. 6x square root of 3. That is in your book. All of these examples are in your book, so if you want to look there, you can. All right, next one. This is 8.4b. All right, now a little bit more difficulty here. So what we're going to do is we're going to multiply these piece by piece. So let's multiply this first, and we're going to get, that's the square root of 60 times the square root of 10. What's 60 times 10? Well, that is going to equal 600. Square root of 600. We're not done yet. Okay, now this one takes a little bit of thinking, and you could reduce it by different things, but remember when I told you that it's best if you use the bigger square roots to reduce? Okay, we could put 4 into that. 4 goes into 600, but it's not the best one to use. So let's write all of them down. 4, 9, 16, 25, 36, 49, 64, 81, 100. All right, we'll check that out. 100 goes into 600, okay? So we get the square root of 100, and that goes 6 times. 6 times 100 equals 600. Now what do we do? Well, solve that out. What is the square root of 100? Well, it's 10, and then we have a square root of 6 left over. So the solution to this would be 10 square root of 6. 10 square root of 6, okay? All right, so it's just a process that you just have to keep going over and keep going over. Let's do one that's a little bit more complicated. You're going to like this one. All right, check this out. This one kind of adds all of the different elements together. It's even got a negative sign, so that's kind of exciting. All right, so we're going to, this one has a coefficient of 1. So we're going to multiply all the coefficients first. All right, what does that give us? Negative 3 times 4 is negative 12. Negative 12 times 1 is negative 12. The coefficients equal negative 12. Now we'll put a square root sign, and we'll multiply all of these numbers. All right, 20 times 6 gives us 120. Okay, 120. Times 18 gives us, I don't know, I don't have that one memorized. So 120 times 18 equals 2,160. 2,160. Ooh, that's a big number. Okay, you're right. But we can figure this out. Okay, we really can. Now, we have some letters. X, X, X. We have to multiply them all. What do we get? We get X cubed. Okay, X times X times X equals X cubed. All right, now what are we going to do? Well, we have to try to simplify this thing. That's a big number to simplify, but we can do it. Okay, we can also, yeah, let's just go ahead and give it a try. So write out your perfect squares. And what you want to do is you want to start with the big one. You can go back to the chart. I think that was on page, I don't remember what page it was on, 280, 270 something. Back there with the chart, table B was what it was called. So go look up table B, and you can use all of those squares there. Start with the biggest one. I think 15 was the biggest square that they gave you. So start with 15 and see if 15 works. So here's what we'll do. We'll take our calculator, and we'll see if 15 works. So 2160 divided by 15 equals 144. Interesting. Okay. So 15 was the number that we needed, but it gave us 144. So you go back to that. So 15 went in 144 times. 144 is a perfect square. That's why I picked it. 15 is not the perfect square. 144 is the perfect square. So I was just testing numbers to see what might work. And boom, we got lucky on the first one. You're not always going to get lucky, trust me. All right, now 144 solves out to 12. So look what we have right here. We have 12 times negative 12, and that's going to be negative 144. And we're left over with the square root of 15. Square root of 15 cannot solve out anymore. We're not done quite yet because we still have this x cubed in there. What does this x cubed factor out to? Well, the perfect square is x squared, and we have an x left over. Okay, what comes out of there? Well, then x comes out. What stays inside? The x also stays inside. So here's what we're left with. Negative 144x square root of 15x. Okay, and that again is in your book on page 285. All right, next one. Again, we're jumping to page 286 here for the next example, but these are all in your books. All right, now we have, check this out. This is different. So we have the fifth root Wow, the fifth root. So that's not square roots anymore. So how are we going to do this one? Well, we'll do it the same way. Let's just work through it, and then when we get to the point that we have to do something with the fifth root, we'll see how you do there. All right, 3 times 4. Just 3 times 4. They're both outside. That's going to give us 12 outside. 16 times 2, and again, this is in the fifth root sign. So 2 times 16 is going to be what? Was that 32? All right, 32. And then x4 times x to the 7th is going to be x to the 11th. X to the 11th. All right, now, we do not have a chart for x to the 5th. Okay, we don't have a chart for the 5th. We have a chart for squared, and we have a chart for cubed. So how are we going to solve this? Well, the way that we're going to solve this is to try to figure out, okay, what number can we solve this out? What number times itself 5 times gives us 32? Well, anytime you're multiplying something times itself 5 times, it gets very, very big very quickly. So I think I would start with the number 2 and just try the number 2. So come over here and let's see what happens. So let's do 2 times 2 times 2 times 2 times 2, 5 times. Okay, 32. So that's right. We did it 5 times and we got 32. So that's right. So what is this down here? Well, it's okay. This one just comes out. It doesn't really factor out because that's a perfect fifth root. I know it's kind of like mind-boggling just a little bit. I'm trying to explain it to you in a way that you can understand. But because it's a fifth root, it's just going to come straight out. What's going to come straight out? The number 2, because 32 is 2 to the 5th power. So multiply that, and we're going to get what? We're going to get 24 outside. And then watch what happens here. What happens here, let me move that 24 just a little bit. I'll move this up. So this comes out to 24. What happens to this? Well, this, we want to break it down into 2 fifth roots. So in other words, we have to get, watch this, x to the 10th and x, or x to the 1. Notice x10, x1, that's our x11. Why did I take it to the 10th power? Because look here, the 5th power. 5 plus 5 equals 10. So there's 2 fifth roots in there. In other words, there's an x5 and an x5. Hopefully that makes sense to you. If it doesn't, check your book, look through it. But that's how you do that. You're just subtracting here. So what are we subtracting? We're subtracting whatever the index is, and that's a 5. So that's going to give us 2, or what's going to come out of this? What's going to come out of this? X squared. Why is it an x squared? Because there are 2, right here, there are 2 x5s in that 10. X squared, there are 2 x to the 5ths in that x10. Okay? And so let me bring this 24 over here. So it's going to be 24 x squared. That also comes out. What's left inside is x with the 5th root. That doesn't look very good. That looks like it's 25. 5th root x. Okay? And that would be your answer. That would be your final answer. There's nothing else you can do. You can't solve that out any further. We've already solved that out as far as we can go. Okay? That was a little bit of a tough one right there, but work on those, practice those, ask questions about those, watch videos on those, rewind that if you need to. All right, let's do, we got 2 more to do, okay? This one here is going to be distributing, okay? Now look, we have a radical out here, and then we have a binomial in here. And yes, there's a number and a radical inside, but it's okay. It's still just a binomial. So we have a monomial times a binomial. How do we do that? We just FOIL it. Okay. So what is 3x 3 square root of 2 times 5? 3 square root of 2 times 5 is 15 square root of 2. 15 square root of 2. So what is 3 square roots of 2 times square root of 3? It is 3 square root of 6. 2 times 3 is 6. Okay? And we're done with that one. How do you know we're done? Well, we can't add those together, can we? What has to be the same to add? Well, that has to be the same, and they're different. And also, we can't simplify the 6. The 6 has no perfect squares that go into it evenly, so we can't simplify it, and we are done with that one. Okay? So circle it. All right, let's do one more, and then we'll be done with this lesson. What we're going to do here is we are going to FOIL. So what we want to do first is the first. The F in FOIL is 3 times 5. Well, what is 3 times 5? It is 15. And then we're going to do the O, so the outers. All right, what is that? Make sure that you attach that sign with that. It's negative square root of 3. So 3 times, remember, there's a 1 out front of that, so it's going to be 1 times 3. So it's going to be negative 3 square roots of 3. Negative 3 square roots of 3. Then we're going to do the inners, these guys inside right there. And so we'll have 5 times the square root of 2, and it's positive, so it's going to be plus 5 square roots of 2. And like I said, there's going to be something interesting that happens right there. Notice that usually when we multiply right there, we get those middle terms can combine, right? Well, look here, we don't have common terms. We don't have same terms. So we can't combine those. So that's an interesting thing that sometimes happens when we multiply these radicals. And the last one would be the last in FOIL, L. So we have square root of 2 times negative square root of 3. So that's going to give us negative square root of 6. Now, what we want to do right now is we want to see what can we solve out. What can we combine? Well, notice 15 doesn't combine with anything because it doesn't have any square roots with it. Square root of 3, there's no other square roots of 3. Square root of 2, there's no other square roots of 2. Square root of 6, there's no other square roots of 6. Guess what? We are done with this. We cannot combine anything. Now, what if we can combine something? Well, then go ahead by all means and combine it. That would be great. If you can. If you can't, then just go ahead and work through it. So there's the different methods, okay? Multiplication, distributing, and then FOIL. And you'll use the different way. You know how to do those. And so just use each one separately when the problem calls for that. Make sure that you remember to follow your signs. If there's a negative sign, it's going to make it negative. If there's positive sign, it would stay positive. Make sure that you're combining your like terms. Make sure that you're doing the things that you know to do. Okay? That's all I have for you today. Hope you learned something. If you missed anything, make sure to slide it back there and take another look at it. We'll see you later. Have a good one. Bye-bye.